Hi Year 9, today what we're doing is areas of sectors, quadrants and semicircles. We can calculate the area inside a semicircle by halving the formula for the area of a circle. So we have the formula A equals a half times pi times r squared, where we have our r to be our radius. We can also calculate the area inside a quadrant by quartering the formula for the area of a circle. This means that we have the formula A equals a quarter times pi r squared, where r is our radius here and the same length going across here. We can calculate the area of a sector by using the formula A equals our angle of theta over 360 times pi r squared. This is where our angle is in the middle here, and we have our radius here and here. Both of these lengths are our radius. Just a reminder that if we are given the diameter, we have to find the radius first by halving the diameter and using the formula radius equals a half times the diameter, or radius equals our diameter over 2. Let's look at some examples. So we want to calculate the area inside these semicircles and quadrants and round to one decimal place. So what we have here is a semicircle. So we need to look at our formula for a semicircle, which is A equals a half times pi times r squared, and that's what we need to write down first. A equals a half times pi times r squared. Now what we will need to do is we'll need to find out what our radius is. And then we will need to substitute in our radius into our formula. So our radius is here, which is 8 centimetres. So we're going to substitute 8 into where we have our r here. So we'll write a half times pi times 8 squared. Now remember, on our calculator, we want to find pi. How we get pi is we go shift and then we hit the times 10 to the power of x button, which is down the bottom near our 0 and next to our decimal point. So on our calculator, we are going to go a half times shift times 10 times 8 squared. And when we do this, we get 100.5309649. Now this question asks us to round to one decimal place. So we did rounding last lesson. What we want to do is we want to look at the number that is after our decimal point, and then we want to look at the number after that, which in this case is a 3. Because the 3 is less than 5, we do not round up. So we leave our answer as 100.5. We're finding area, so we need our units of centimetres squared. For B, we want to calculate the area inside. This is also a semicircle. So our first step is to write our formula, a half times pi times r squared. Now you will notice that we do not have a radius, we have a diameter. So we want to use the formula r equals d divided by 2, which is our diameter. So our diameter is 14 divided by 2. So our radius is equal to 7. So then we want to substitute in our radius into our formula. So we'll have a line saying a half times pi times 7 squared. And then we put that into our calculator. So we go a half times shift times 10 to get our pi times 7 squared. And we get an answer of 76.969.02001. Remember, we are rounding to one decimal place. So we look at our number after our decimal place, and then we look at the number after that. And because that is greater than 5, we have to round up. So we have to add 1 to the 9. So what this does is that makes that 9 a 10. So we then have to add 1 to our 6 there, which means our answer will be 70 meters squared. For C, we have a quadrant, okay? It's a quarter of a circle. So we want to use the formula a quarter times pi times r squared. Okay, we need to identify our radius. That's our only variable here, and our radius is worth 4 centimeters. So let's substitute that in. We'll have a quarter times pi times 4 squared. Now we want to put that into our calculator by going a quarter times pi times 4 squared. When we do this, we get 12.56637061. Now to round this to one decimal place, we highlight the number after the decimal place and we check if the second number is greater than or equal to 5, which it is, so we add 1 to that last number there, so we get to 12.6 centimeters squared. What we want to do for example 2, we want to write the fraction of a circle with a denominator of 360, then simplify. So we have a sector of a circle here, and we have been given this angle of 40 here. Now a full circle adds up to 360 degrees. So what we want to do is we want to find out how much of a circle we have. So we're going to put our angle in here, into this box, which is 40 degrees. Then on our calculator, we want to go 40 over 360. So on calculator, we go 40 over 360, and then we write our answer in the box. And so 40 over 360 simplifies down to be 1 on 9. For B, we have the angle in the middle here, 150. So again, we want to put that on our top box there because we have 150 degrees of a circle out of a total of 360. We then, on our calculator, want to go 150 over 360. So 150 over 360, and we get it simplified down to 5 over 12. Now what we're going to do, lucky last, is find the areas of these sectors and round to 2 decimal places. So when we're finding the area of a sector, we use the formula our angle, or theta, over 360 times pi times r squared. Oh, we have not been given a radius for these ones. We are going to say that the radius on the first one is 5 centimeters, and our radius on the second example here is 8 centimeters. So if you can just fill that in for me, please. So what we want to identify is our radius. So our radius here is 5. And then we want our angle. So our angle here is 240. So we want to substitute these two values in. So we'll have 240 over 360 times pi times 5 squared, like so. We then want to put this into our calculator. So 240 over 360 times, shift times 10 to get our pi, times 5 squared, and we get our answer of 52.35987756. And we want to, on this one, round to 2 decimal places. So we want 2 numbers after the decimal point. Our third number is what we look at. If our third number is greater than, oops, what happened there? Is greater than or equal to 5, we round up. Okay, so our third number is 9, which is greater than or equal to 5. So we're going to add 1 to our 35. So we'll get 52.36 and our units of centimeters squared. For our last one, again, we're finding the area of the sector. So we use the formula theta over 360 times pi times r squared, where our theta here is our angle of 160 and our r here stands for our radius of 8. So we want to substitute in these numbers. So we have 160 on 360 times pi times our radius of 8 squared, Again, we put that into our calculator, so 160 over 360 times pi times 8 squared. And when we do this, we get 89.3, that's a 6, sorry, 3608577. And finally, we want to round to 2 decimal points. The number, our third number there, is less than 5. So what we do is we don't round up. So when less than 5, do not round up. So that means that our answer will be 89.36.